So welcome back. This is our third example. And for the first example, I have 2x squared plus 8x plus 12. And I would like you to solve this quadratic equation by completing the square. And again, it's not factorable because there's no two numbers that add to 8 and the same two numbers that multiply to positive 24. Okay. Um, so they are not, we don't have any it's not factorable. So that's why completing the square is a good method to learn. So you can basically solve any kind of quadratic equation. It's the same as the quadratic formula. Okay. So please pause the video. Okay, and follow the steps that I've shown you before for solving quadratic equation by completing the square. Okay, so there are 6 steps, and for this example here, you're going to do step 2. Why? Because x squared is not alone. Basically, the coefficient of x squared is 2, not 1 anymore. So please complete step 1, 2, 3, 4, 5, and 6 in this correct order. Okay? Thank you. Okay, so what I'm going to go over the steps, each one of them. Okay, so step 1 is to collect the variable term on the left side and the constants on the right side. Okay, so here I have to move the positive 12 to the other side. So that's why I minus 12. Okay, I minus 12 on both sides. Then the equation is going to be 2x squared plus 8x equal negative 12. Now for step 2, I have to do step 2 here because x squared is not alone. Okay, basically the coefficient of x squared is not 1 anymore. It's a number over than 1, which is 2. So what am I going to do? You're going to divide by 2 on both sides. And some of you will have noticed, okay, should divide by 2 on both sides. I could actually divide by 2 because 2, 8, and 12 are divisible by 2. So why not divide by 2 from the beginning? And I will say, just to avoid, I will say it's nice because all the 2, 8, and 12 were divisible by 2. Okay, and that's why we're able to divide by 2. But in some case, you will not get so those number being so nice. We could have ended up here with 5x or 13. So so instead of having each number to be even, you could have given 2 here and 5 and 13 here. So I would say, as a good practice, to avoid just move first the constant to the other side. Okay, in case when you have a 13, if you have to divide, negative 15 divided by 2, you will not have a fraction to move around. So I'm just trying to make life easy on you. So follow the steps. So again, step 2 here, you have to divide by 2. Okay, and you end up having now x squared plus 4x. So you have to complete the square. What number would you add here to get the perfect square trinomial? And that number is half of b, which is 2, and the square is 4. So you have to add 4 on both sides. Okay. And then for step 4, you can now factor y the left side as a perfect square, which is going to be x plus 2, everything squared. Okay. And then you end up on the right side with negative 2. And then to solve for x, you're going to take the square root on both sides. And then you get x alone. So now what I want to notice here is we know that the square root of a negative number is going to be an imaginary number. Okay? So we simplify square root of negative 2 to I square root of 2. So you're going to get x plus 2 equal plus minus I square root of 2. Okay? And I believe you know how to do this because you've done in class. Okay? And then to get x alone, you minus 2 on both sides. And again, you have 2 solutions. That's why I wrote one with the negative minus I squared of 2, and another one is positive. Okay, so now some of you will say, okay, I can see the square roots, so the solutions are irrational. You have 2 irrational solutions. Some of you may say that. No, that's not true. And the reason is the I is overpowering the irrational thinking. Okay, every time you see I, okay, the number is not anymore real. We are not anymore in the real number system. We are now moved to the complex, to the imaginary numbers. Okay, So we cannot say that both solutions are two irrational solutions because you can see the square root. But you can also see the I, right? So the solutions are just imaginary numbers. And the imaginary numbers are number, instead of having rational numbers, it's just irrational. Okay, the B here is irrational. Okay, again, each number is written in the form of A plus BI, again, A minus BI. And we call those two complex numbers complex conjugates. And the reason is complex conjugates are the same real part, okay, and opposite imaginary part. Okay, that's why we have two complex conjugates. Okay, thank you for listening to my and watching my video. I hope this video was helpful. Have a wonderful day and see you until the next one. Bye bye.